So for this worksheet, when we're talking about the domain and range of that bouncing ball, we're asking, like, we know the ball came from up, it goes up a little bit, it comes down, goes up a little bit, and each time we're looking at it's bouncing. This is the first bounce, the second bounce, the third bounce, the fourth, and we just keep going with that. So the data that we're looking at is, one is the height of the ball. We're looking at the height of the ball right here this way, the vertical height of the ball, and we're looking at the number of times the ball bounces. So when we think about the context of the problem and what the domain represents and what the range represents, if I was to graph this problem, one of them would be an x value and one would be the y value. If I draw a graph and I label the axes, what am I going to label the x? And what am I going to label the y? Well, the y is going to be the height of the ball, right? And the x is going to be the number of times it bounces. In this way, the domain is the number of bounces, and the y, the range, is the height of the ball. So that's what you're going to put there. And then when you're looking at the problem E here, it's going to ask you, no, that wasn't right. Oh well. When you're looking at E, it's asking you to put the domain and range in inequality notation. So, all right, if I graph this, what I find is that at 0, this ball was at 16 feet. At 1, it was at 8. It's about halfway down. At 2, it was halfway that at 4. At 3, and this isn't all the way to scale, it'd be at 2. At 4, it would be at 1. And then at 5, it keeps going in half. So at 5, it's at 1/2, and that's at 1/4 at 6, because I keep breaking it in half. So the graph, as I notice, it's falling, and it's getting really small in the fractions, really small. But it's never really crossing the x-axis. And that's because I can keep cutting that fraction. So it goes 1/2, and I cut that fraction in half, I get 1/4, because that's half. This is half of 1/2. And then I get 1/8, and then I'm going to get 1/16. And you see, I can keep going with this indefinitely, because it's math. We just keep making bigger numbers on the bottom of the fraction. I mean, in reality, would we see the ball bounce like that? Probably not. It eventually stopped bouncing. But in math, we could just keep cutting that fraction indefinitely. And for that reason, the domain is going to be infinite to x. So our domain is going to look like this. It's going to be starting at the 0, because there are no negative x values, and it's going to be greater than or equal to, because x is 0, y is 16. That's our first point, x. And then that's going to be less than or equal to infinity, because as we said before, it just keeps going. Then if we look at the range in the same graph, which the graph was like this, where this one here, where it touched this, it was 16, 0, 16. Where do the y's stop? Well, they stop up here at 16. That's where they start, I guess, so to speak. So the highest the y's ever get is 16. Well, what's the lowest y's ever get? They never cross the x-axis, so the lowest y is going to get is 0, but it's never going to get to 0. So what it's going to be is 0, and y is going to be greater than, but not equal to, because it's never going to touch that. And we're going to say y, and then we're going to say greater than or equal to 16. And that's going to be your range. So that's your domain, that's your range.